Argon, the third most abundant gas in the atmosphere. Completely inert. In fact, so inert and so boring that its discoverer named it, quite literally, lazy. But surely there's got to be something interesting about this noble gas, right? Well, the light that you are seeing is a result of argon's atomic emission spectra. This happens when a high voltage is applied and the electrons jump up in energy state, and as they relax back down to their ground state, they emit this magnificent blue light. This isn't anything special, however. In fact, every single element has its own unique spectrum and colours. Anyway, I figured I should try and make the most boring element interesting, so let's make some Argon Ice. In fact, argon is not entirely inert, and it has been found in outer space, more specifically in the Crab Nebula, in the form of argon hydride, also known as Argonium. This can only occur since the argon gas is just being ionized constantly from the high energy cosmic rays.
Argon is actually twice the density of normal air. So, like helium, we can actually inhale this and see if it changes our voice. So this is my voice before. And this is my voice on argon. You can see it's slightly deeper, but there isn't actually that much difference compared to normal air. It's quite hard to get it out of your lungs because it is heavier, so it just sits in your lungs for a bit longer.
What I am doing now is just attaching a balloon of argon to a test tube, which will then be cooled in liquid nitrogen, and we should be able to get some argon ice. A lot of interstellar argon is actually argon-36. Almost all of the argon on Earth, however, is argon-40, and this is a result of the radioactive decay of potassium-40, which is found naturally in rocks. Most of the isotopes of argon have escaped the atmosphere. This accounts for the discrepancy which is seen on the periodic table, with argon actually being heavier but having less protons. And yeah, if you are wondering, I calculated you would need the potassium of approximately this many bananas and a bit more than 1 billion years just to obtain 1 litre of argon-40. I wish that was a joke. Anyway, let's see how our argon ice is coming along. Because this was a closed system, the balloon has been sucked in as the pressure has been reduced, and we can see that the argon is now white and polycrystalline. This is very similar to what happens with water in the upper atmosphere as snow forms because of the lower pressure. Argon freezes at around -189 C and boils at around -186, giving it a very narrow liquid phase, unlike water, which has more strong intermolecular interactions, giving it a 100-degree liquid phase. These interactions are the same reason that the argon ice rapidly melts. I tried this method several times and it was quite fun heating up the test tube just to reinflate the balloon. Annoyingly though, removing the balloon would also cause the argon to melt, which isn't really what I wanted. And I think this happened due to the presence of air getting into the test tube, as gas mixtures had different freezing points. Doing some research, I came across a really nice video by the Royal Institution, where their technician Andrew uses essentially some modified standard lab equipment to get some really nice frozen argon, and I thought I should try this out myself. The first thing I need to do is submerge a modified filtration flask hooked up to my argon line into some liquid nitrogen. With a continuous flow of argon going through the flask, I can then attach a balloon and cut the flask off to any more argon. After some time, I had a nice amount of pure liquid argon starting to form in the bottom of the flask. There are probably other ways to do this in a closed system with something like a balloon or pressure valve to account for pressure changes, but shout out to the RI for this method as it is very convenient. Once I felt I had enough liquid argon, I next purged a test tube with argon. This isn't in the protocol, but I wanted to ensure extra purity before cooling the tube in liquid nitrogen. I then decided to transfer the argon to the test tube. I should have really worn gloves here, but I figured if I did it quick enough, I should be fine. On inspection, we can start to see the solid argon forming in the bottom of the test tube. After around 10 minutes or so, I decided it should be done. So I'm now going to pour out some of the solid argon ice.
Winter is coming.
At first, there is quite a lot of cold liquid argon which comes out, but after a firm hit, a nice pellet of Argon Ice has clearly formed. And at minus 189 C, this is the coldest ice I have ever witnessed.